Section 3.1 in Trig is going to first talk about what's called a reference angle. Now, we've actually talked about reference angles a little bit, but they are the positive acute angle that is formed between the terminal side and the x-axis. So, just to give you a little picture reference, this is our coordinate plane. If we have an angle drawn over here, let's say this is 135 degrees. Theta is 135, but his reference angle would be how far away he is from the nearest x-axis. So in this case, it would be that axis right there. And since this is 180 degrees, we do 180 minus 135 and get a reference angle of 45 degrees. For this book, they always define theta, and the reference angles are signified with theta hat. There's like a little upside down V on top of it. It's called theta hat. It's always positive, and between 0 and 90, meaning it's acute. So, let's look at some examples. Name the reference angles for the following angles. Now, we've taken the liberty of having them drawn for you. So, a 30-degree angle is already a positive acute angle, so he actually is his own reference angle. Now, 135 was the example we just did. So, how far away is he from 180? He's 45 degrees, so his reference angle is 45 degrees. 240 extends 60 degrees beyond the 180, so his reference angle is 60 degrees. And then 330 is almost all the way around. Remember, this is 360 when you do a full rotation, so his reference angle is 30 degrees. And they can give you some formulas here. If theta is contained in quadrant 1, then his reference angle is just whatever theta is. For example, 30 degrees was his own reference angle. If theta is contained in quadrant 2, then his reference angle can be found by taking 180 and subtracting the original angle. If he's in quadrant 3, then he's whatever the angle is minus the 180. And if he's in quadrant 4, then you can find it by taking 360 and subtracting the angle. You don't really need to bother using those formulas or memorizing them, because usually when you draw a picture, that's good enough for most people that they can figure out reference angles that way. We've actually done this. So as you can see, any angle with reference angle 30 degrees will have a sine of 1/2 or negative 1/2, and that's because these are all related to each other. So if this is positive 30 degrees, his sine is 1/2. But if you go over in this quadrant, he's also 1/2, but remember, you're all students, take calculus, little mnemonic device, so sine is positive in quadrant 1 and 2. When you go down to quadrant 3, this time your sine is going to be a negative 1/2, and that's because he's going down 1 unit in the y direction over hypotenuse of 2. And then similarly here in quadrant 4, down 1 unit, so that's why his sine value is a negative 1/2. Now, I kind of do something that's not really appropriate when I draw these, is I label the sides of the triangle with positive and negative values. So I would name this a negative square root of 3 and a negative 1. But that is completely up to you if you want to continue to do that, or what we're going to do instead is we could follow these 4 steps right here. So the first thing we would do is find his reference angle. So that's going to be something between 0 and 90. We're going to determine whether he's positive or negative, the trigonometric function, in the quadrant in which we terminate or land. We're going to write down the original trig function's value from the reference angle, and we might have to adjust the sign. So I'm going to do this first question the way they align in your book, and I'm going to show you the way that we have been doing them, which is not really quite technically right, but it works. I'm kind of doing something illegal by saying that the sides of a triangle are negative. But let's look. So our first example is sine of 140. So step 1, if you go back to your steps, said find the reference angle. So his reference angle, and you could draw yourself a little picture. 240 is down here. So he would be 240 minus the 180 is 60 degrees. So if you look at your unit circle, and I really don't need the whole unit circle, I just need the first quadrant. So I'm going to kind of sketch one here for us. Oh, that is really unattractive. Alright, so let's say this is 30 degrees, and this is 45 degrees, and this is 60 degrees. At 30 degrees, on the first quadrant of the unit circle, remember he's square root of 3 over 2, and then 1/2. At 45 degrees, he's square root of 2 over 2 for both. And then at 60 degrees, he is 1/2 comma square root of 3 over 2. So, at 60 degrees, we're trying to figure out what exactly? The sine. So at 60 degrees, the sine of 60 is square root of 3 over 2. Let's see, I never follow these steps, so I have to go back and look at what they want us to do. So, in this quadrant down here, where he actually lands, the third quadrant, we have to decide whether he's a positive or negative function. So sine in the third quadrant is negative. So in quadrant 3, sine is less than 0 or negative. So I'm going to write down a negative symbol, and then what follows is just the sine of the 60-degree angle. So, let's see, sine we said was square root of 3 over 2. Do you remember, discussed briefly that cosine was the x value and sine was the y value? So our answer here is negative square root of 3 over 2. I'm going to do that same problem the other way we have been doing it. So I'm going to go ahead and draw the 240-degree angle. Whoops, that was really ugly, I'm sorry. And remember, this was a 60-degree reference angle. Oh my goodness, that's terrible. Alright, so his y value, remember, if we kind of think of the radius as being, well, let's actually do something else. Let's call, remember we can say the sides or whatever we want. So let's say this is -1 units over to the left. Then the hypotenuse, remember, is double the length, but radius is always positive, so I'm going to call that 2. And then that would leave this to be square root of 3, but I'm going to call it a negative square root of 3 because it's moving down. So off of this given triangle, even though we're not technically supposed to have negative sides, I still label them that way. Remember, sine would be y over r, and we would have ended up with the same exact answer. So it doesn't really matter how you do this question. What's really important, though, is when you're done answering the question, do a quick double take. Is your sine, cosine, tangent, whatever you're working with, is it supposed to be positive or negative for where the angle terminates? So exact value for tan of 315. They drew the angle in for you. His reference angle is obviously 45. So if you go back to our little quick drawing of the first quadrant, 45 degrees is square root of 2 over 2 for both the cosine and the sine. But this time they want tangent. Well, remember, tangent's formula is sine over cosine. And for 45s, that's actually really easy because square root of 2 over 2 divided by square root of 2 over 2 is just going to be a 1. Now we got to think about signs, meaning positive and negative. So in the fourth quadrant where it terminates, the tangent is supposed to be negative. So what I'm going to say is the tangent of 315 is equal to the number 1, except since he's in that quadrant, he's a -1. Okay, our fourth example. This time we want cosecant of 300, so they've taken the liberty of drawing it for us. And we have to remember, cosecant is the buddy of sine. So he's going to be the reciprocal, the sine of 300. Now they already told us by the picture that the reference angle is 60, and I have to remember that all students take calculus, which means any sine or cosecant function would be a negative value. So I'm going to go ahead and write down the negative. And I need to calculate now what the sine is at 60 degrees. So you can go back, whoops, too far. You can go back here, remember cosine sine, square root of 3 over 2. Oh, goodness. So I have negative, because of the quadrant, 1 over square root of 3 over 2, which if I rewrote that as -2 over square root of 3, and then I rationalized the top and bottom, meaning I multiplied by square root of 3 on top and bottom, we'd get the value of -2 square root of 3 over 3. Now, on a few quizzes back, some of you tried to give me decimal answers for these types of questions, and because it says find the exact value, you can't use your calculator in that way. Okay, so coterminal angles are differ each other by 360 degrees, meaning you can either add or subtract groups of 360. So, unfortunately, in trig, there's not just one angle that is coterminal. There's lots and lots and lots of different angles. So what we're going to say is, instead of just adding and subtracting 360, we're going to write it as adding and subtracting groups of 360k. Now I differ from your book a little bit. They just put plus 360. I'm going to put plus and minus. But let's continue. The question is, find the exact value of negative 690. So if I take negative 690 and I add 360, that's not going to be positive yet. So I'm going to add 360 again. And I think that brings us up to 30 degrees. So I don't know what they want exactly. They don't tell us. I think they wanted something like, what was the cosine or sine? I'm not sure. I'm not sure what they're going for here, so we're just going to skip it. I tell you, one day when I get to rewrite these notes, they're going to look beautiful. Okay. They next talk to you about approximations, and we've actually done this, so we're in good shape. We are going to have to apply the sine functions to some angles. So sine of 250, make sure your calculator is in degree mode when you type this in. And when you type it in, I'm not going to bother getting my calculator out because this is pretty easy for us. We get negative 0.94, negative 0.34, and 2.75. Now when you type in sine of negative 160, you get negative 0.34, negative 0.94, and then tan of negative 160 is 0.36. Okay. You might notice there's something kind of interesting going on here. The sine of 250 is the same as the cosine of negative 160. And if you were to add those two angles together, kind of strange to have a negative angle, but they are complementary in respect that they add up to 90 degrees. So I don't know if you find that interesting, but okay. Next, when we have to type in the cosecant of 250, remember we can't type in cosecant, we have to type 1 over sine of 250. And when we get that, we get negative 1.06. 1 over cosine, which is secant of 250, is negative 2.92. And cotangent of 250 is 0.34. Now just to kind of bring everything home here, let's think about this for our quadrants. 250 is over here in quadrant 3, so the only function that should have been positive would be tangent and cotangent, and if you notice your examples here, gave you negative calculations for cosecant and secant, but positive for cotangent, so good to know. Moving on. Okay. This will come back to the adding and subtracting 360 stuff. So find theta if the sine of theta is negative 0.5592 and theta terminates in quadrant 3 and it's between 0 and 360. So they're just eliminating the option of us giving them a negative theta. So let's see here. What do we want to do? Okay, let's use your calculator. So remember to undo a sign on our calculator, make sure you're in degree mode, and you're going to hit inverse sine of negative 0.5592. And you are going to end up with theta coming out to negative 34 degrees. Now, if you think about this, I'm going to draw myself something. Right here is negative 34 degrees. Remember, theta is technically a reference angle in this case. So his reference angle is 34 degrees. So if I go back to quadrant 3 and I need a reference angle of 34, that would be 180 plus the 34 degree reference angle, which gets us to 214 degrees. Another way to do this problem, I'm going to do this one in red, is some people will only find the positive angle, meaning the original angle, the reference angle from the first quadrant. So what they will type in is inverse sine, and because sine is always positive, everything's positive in the first quadrant, they'll just type in positive 5592 and get their reference angle of 34 degrees. And then they'll go back to their visualization, or maybe even their drawing, and say, okay, if I have to be in quadrant 3, then I need to go from 180 and add a reference angle of 34 degrees, and that's another way you can arrive at the same exact answer. This is kind of the way your book explains it, so maybe that's the way we'll continue, just for cohesiveness. Now, unfortunately, we want to list all angles that terminate in quadrant 3 and have a sign of that. So, in some of your books, maybe when you go to college, they'll write 214 degrees, and then they'll say plus and minus 360K. And that would be a list of every single angle in the world that would have a sign of negative 0.5592. Now remember, your book only said plus, and I'm going to say plus and minus. So, and that would reflect every single angle that is coterminal with 214 degrees, positive and negative. Oh, I only have a couple of minutes here. I might have to go fast. So, let's first find our reference angle for this example, and let's go ahead and do it the way your book does. So, inverse tangent, instead of negative 0.8541, we'll do positive 0.8541, and we'll come up with a reference angle of, and I'm going to cheat because I already did this, 40.5. So I'm very visual, so I need to see this. We're in quadrant 4. So if it's a reference angle of 40.5, that would be going down from 360, so I'm going to do 360 minus the 40.5, and that gives us 319.5. So that's one of our angles, but remember, we want all angles. So what we're going to say is 319.5 degrees plus and minus groups of, oh my goodness, try again, 360K. That would be your solution. And that's the way I want it written in your book. So our next example has sine of theta as negative 1/2. So again, we're going to find the reference angle, as your book does, by doing the inverse sine of positive 1/2, and that's an easy one because that's off of our unit circle. So that would be at 30 degrees, and remember that's a reference angle, so I'm going to draw myself what's going on here. We're going to be in quadrant 3, and if I have a reference angle of 30 degrees in quadrant 3, that means I'm going to go past 180 degrees, 30 degrees, which is 210 degrees. Now remember, we want all angles, so we're going to add and subtract groups of 360. Alright, a couple more. I'm going to try to get done before the bell rings. Similarly, we're going to, well, this is already positive, so we don't have to worry about that, but it's secant. So we got to think about how to type this in. Remember, you do the inverse cosine, because that's his reciprocal, and then the reciprocal of the number. And it's already positive, so don't worry about that. And this will give us our reference angle, which is 75 degrees, but they want us to be in quadrant 4. So if I think about having a reference angle of 75, that would take us back from 360, 75 degrees, which gives us 285 degrees. So our solutions are 285, add and subtract groups of 360. Alright, and then example 10. Cotangent would be the reciprocal of tangent, so inverse tangent, and then remember we're just going to find the reference angle at this minute. So I'm going to do positive 1 over 1.6003 and get a reference angle of roughly, I don't know if it's exact, or roughly 32 degrees, and they want us to be in quadrant 2. So if this is 32 degree reference angle, that means we're going to back up 32 degrees from 180, and that gives us 148 degrees. And then I just panicked because my key was wrong. So 148 degrees, that sounds right, yep. So remember, we want, and it is negative in that quadrant, we want all the solutions. So it's 148 degrees, and we're going to add and subtract groups of 360. So this back part of your notes we're actually going to do as a competitive game. So if you are doing this ahead of time, go ahead and study how to do this, and maybe your group will win. Good luck.